Today in science class, we're going to take a look at and continue our study in particle motion and energy by doing IXL J.3 and J.4. Here on your weekly checklist, you can click right on the link and open up J.3. J.3 is all about answering the question, how does particle motion affect gas pressure? How do the particles that are moving around influence the pressure that something has, pressure of that fluid, inside or outside of a container? In the first stage, we have to answer 5 out of our 6 questions correctly. Let's give it a shot. All substances are made up of small particles of matter that are constantly moving. In a gas, these particles can move freely and tend to be far from one another. In fact, the space a gas takes up is mostly empty. Gas particles move quickly and randomly. They travel in straight lines, changing direction. When they collide with each other or with walls of their container, even though there is a lot of space between particles in gas, collisions often frequently occur because the particles are moving so fast. Which of the following statements are true about gas particles? Select all that apply. Gas particles are tightly packed together. That's not true. They're spread apart. Gas particles rarely collide with each other. That's not true. They're moving so fast that they collide quite often. And gas particles are always moving. So the only one true is that last one. How fast do gas particles move? At room temperature, the average air particle travels at a speed of about 500 meters per second or 1,000 miles per hour. When gas particles collide with the walls of the container, the particles push on the walls. Together, these forces cause gas pressure. Gas pressure is what makes objects such as a bike tire or beach ball feel firm when they're inflated. A gas's pressure depends on both the total force exerted by its particles and the area that force is spread over. The more force the particles exert over a given area, the higher the gas pressure. Which of the following statements are true? Select all that apply. Gas particles pull on the walls of the container. No, they push on the walls of their container. Gas pressure is caused by gas particles colliding with each other. Because of gas pressure, a balloon feels firm when it's filled with helium gas. And gas pressure depends on the total force exerted by its particles on the container walls. So gas pressure is caused by particles colliding with each other. It's colliding with the wall than it is them colliding with each other. But gas pressure does depend on the total force exerted by the particles on the actual walls. So not when they're providing pressure on each other, but on the walls themselves. Liquid pressure. Like gases and solids, liquids also exert pressure. Liquid pressure is the force a fluid exerts on this object that it's submerged in liquid. Liquid pressure depends on the depth of the object. A deep-sea fish swimming 1 mile below the ocean surface experiences nearly 150 times as much liquid pressure as a fish near the surface. Maybe you've gone swimming and you've dived down in the water. The deeper you go, the more you feel that pressure exerted on you because there's obviously more water that's on you and above you at that point. Gas pressure is caused by the force exerted by gas particles when they collide with the walls of their container. Gas particles can exert more force on the container wall when the particles are moving faster. This is because particles that are moving faster collide with the container walls more often. Faster moving particles also have more kinetic energy. When a particle has more kinetic energy, it exerts a greater force when it collides. The diagram below shows 2 pure samples of gas in identical closed rigid containers. Each sample contains the same number of gas particles. Each particle in gas A and gas B have the same mass. The particles in gas A are moving at a higher average speed than the particles in gas B. In which gas do the particles have a higher average kinetic energy? Well, if they're moving faster and they have the same mass, the higher average kinetic energy is going to be in gas A. Which has the higher gas pressure? Well, those particles are moving faster in gas A, then the pressure is going to be greater in gas A as well. A heavier particle has more kinetic energy than a lighter particle moving at the same speed, so the heavier particles exert a greater force when it collides with the walls of its container. The diagram below shows 2 pure samples of gas in identical closed rigid containers. Each sample contains the same number of particles. The particles in gas A and B are moving at the same speed. Each particle in gas B has more mass. Well, we just read that if it has more mass and it's moving at the same speed, it will exert a higher amount of kinetic energy and then therefore a higher amount of pressure. So we're going with gas B for both of these. Well done. Diagram below again has our identical containers. The particles in gas A and gas B are moving at the same average speed. Each particle has the same mass, which has the higher pressure. Now, this might be a trick question. If they're moving at the same speed, it might depend on how many particles there are in each. So let's count them. In gas A, I have 1, 2, 3, 4, 5, 6, 7, 8. In gas B, I have 1, 2, 3, 4, 5, 6, 7, 8. If all three of those factors are the same, the number of particles, the average speed of those particles, and the mass of those particles, they're going to have the same exact pressure. Diagram below shows 3 pure samples of identical gas in these closed containers. Each sample contains the same number of gas particles. The particles in gas A and C are moving at the same average speed, while the particles in gas B are moving at a higher average speed. Each particle in gas A and B has the same mass, while each particle in gas C has less mass. So A and C are moving at the same speed, and B is moving at a higher average speed. So I'm automatically going to say B has a higher pressure than A or C because it's moving at a faster speed. I also learn, if I read the second sentence, each particle in gas A and B has the same mass. So A and B have the same mass, therefore B is going to be the highest level of pressure. A is going to be next because A and C are moving at the same speed, but A is actually heavier than C. So my order B, A, C shows which of these pressures are in order based on the factors that are given. Nice work. The pressure of a gas depends in part on the kinetic energy of its particles. This average kinetic energy is directly related to the gas's temperature. The higher a gas's temperature, the higher the average kinetic energy of its particles. If two gases have the same temperature, their particles have the same average kinetic energy. The statement below is about a gas in a closed, rigid container. Click the blue words to correct the statement. The temperature of the gas increases, the average kinetic energy of its particles increases. So the gas will have a higher gas pressure. Diagram below has 2 pure samples of gas in these identical containers. Gas A and gas B have the same temperature, which has the higher gas pressure. Well, again, if they have the same temperature, we should probably check the number of particles. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All three of those factors are the same. We'd say that they have the same pressure. Remember that the amount of gas pressure a gas has depends on the total amount of force it's exerted on the walls of the container. When a gas has more particles, the particles together can exert more force. Now we might want to count those particles. Gas A and gas B have the same temperature. Look at the number of particles in each gas, which has a higher gas pressure. This one has gas A 1, 2, 3, 4, 5, 6, 7, 8, 9. This one has 1, 2, 3, 4, 5, 6. Gas A has more. It's going to have a higher pressure. The diagram below shows 2 pure samples of gas in identical closed rigid containers. Gas B has a higher temperature than gas A. There are also more particles in gas B than in gas A, which has a higher gas pressure. Well, a higher temperature results in higher pressure, and more particles results in higher pressure. Therefore, gas B is going to be our best bet. Imagine 2 pure samples of gas in identical closed rigid containers, gas A and gas B. Gas A has a higher gas pressure than gas B. Which gas particles exert a greater force on the walls of the container? If there's a higher pressure in gas B, it's gas B. What factors could contribute to this difference? The temperature of the gas and the number of particles. Both of those contribute to an increase in pressure. Oh, Mr. Shane was wrong. This mentioned that when I read this, which gas particles exert a greater force? Gas A has a higher gas pressure than gas B. Sorry, I read that wrong. I thought it said gas B when I put these two together. It was A, but both of those factors at the bottom were correct. My mistake. Bonus stage. Which of the following statements are true about gas particles? Gas particles are constantly moving. They don't tend to be close together, and they do collide. We did that one already. Which has the higher gas pressure? Gas A and gas B, they've got the same temperature. Then it depends on the number of particles. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. They have the same temperature, or same pressure. Imagine 2 pure samples of gas in the container, gas A and gas B. Gas B has a higher gas pressure than gas A. Here I'm going to get this one right. Gas B, temperature, number of particles. See how it came back to that question, gave me another chance to fix it, and we got it right. If you followed along, hopefully that helps you with completing J.3. I will go back and click on the link for J.4, and we're going to take care of understanding how to identify how particle motion affects temperature and pressure. As in, we now know that pressure is influenced by a higher temperature and higher average kinetic energy and higher mass. Well, how does that motion directly relate to temperature and pressure as well? You see that these are really closely connected. Diagram below shows our two containers, sample A and sample B. This way it's going to present information a little bit differently, which it has the mass of each particle listed and then the average particle speed shown here. Based on what we know, the one that has larger mass and one that has the higher speed will have the higher overall temperature and pressure. Here it says compare the average kinetic energies of the particles in each sample. Which sample has the higher temperature? Well, if we've got the exact same speed and they've got the exact same mass, the only factor that could be different is the number of particles. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All three factors are the same. We're going to say they have the same temperature. How did I do that wrong? Oh, I didn't notice that this was 1300 instead of 1100. Look at the particle speed. That's going to be your biggest factor. Learn from your mistakes. Got it. Here in our next sample, we've got a mass of 32 and a mass of 16. A higher particle speed in sample A than in sample B. We're going to say that sample A has that higher value. Here again, sample A and sample B. Higher mass, same average speed, but because it has a higher mass overall, it's going to have the higher overall amount of kinetic energy, therefore a higher temperature. Here again, 30 and 30, 1400 and 1200. If they have the same mass in the particles, we're looking at sample A as having a greater number, but the last factor to contribute would be the number of particles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The biggest factor here is the average particle speed, so sample A is going to be our best bet. Sample A and sample B, 36, 36, 560, 560. Which one has the higher temperature? Take a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They've got all three factors that are the same. They should be the same temperature. I got that one right. Next stage. Here we're saying which has a higher pressure based on temperature. If you have a higher temperature, those particles are moving faster, those particles are hitting the walls more, therefore creating more pressure. So higher temperature is going to be the result. The other factor would be the number of particles. In this case, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Same number of particles. Sample B has a higher temperature. Sample B is going to give us the higher pressure, therefore. Sample A and sample B. Sample B has a temperature of 110 degrees. Sample A is 105 degrees. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Sample B has more particles and a higher temperature. Sample B is going to have a higher pressure. Sample A, sample B. I'm looking at the temperatures that are exactly the same. Now I need to count the number of particles. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same temperature, same number of particles, same pressure. I clicked the wrong button. I should have clicked neither have the same pressure. Got it. Sorry, silly mistake. Sample A, sample B. One's 130, one's 135. We're going to say that sample B has the higher gas pressure because of higher temperature. Let's count the number of particles. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same number of particles. Sample B is going to have the higher temperature. Sample A, sample B. Same temperatures. Count the particles. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Sample B is going to have the higher temperature because it's got more particles. Therefore, more of those particles are pushing on the walls, creating a higher pressure. Sample A, sample B. Sample A has a higher temperature. Sample A is going to have a higher overall pressure. Last portion. Mass of each particle, 3246, 53620, which has the higher temperature. Higher speed, higher mass, sample B, which is the higher gas pressure. If it's got the higher temperature, it's got the higher gas pressure. Those are both sample B. Sample A, sample B. Mass of each particle is the same. Average speed is greater in sample A, and the last factor would be the number of pressure or particles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they have the same. The only factor that's different is average particle speed. So sample A has a higher temperature because of that particle speed. Sample A also has a higher gas pressure because of that particle speed. Sample A, sample B, same mass, same average speed. Third factor is the number of particles. You can tell that sample A has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sample B only has 1, 2, 3, 4, 5, and 6. So sample A has higher particles, which is going to increase that pressure and increase that temperature. Oh man, another one wrong. They have the same temperature because they're moving at the same speed. That makes sense. They have a higher pressure because there's more particles in there. So the temperature would be the same. The number of particles would increase the pressure in sample A. So average speed is the same. They're going to have a higher temperature in this factor. Learn from your mistakes. Diagram below shows two of these samples again. Sample A and sample B have the same number of mass, the same average speed. Now the number of particles. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think sample B is going to have a higher. Nope, they're going to have the same temperature. Sample B is going to have a higher gas pressure. This is the question that Mr. Shane just got wrong, so let's learn from that mistake. Got it. Mass of each particle, 32, 30, 1700, and 1500 in terms of average speed. Both of these factors are greater in sample A, so our temperature and pressure are going to be greater in sample A. Sample A has 17, 28, 15, 15. The mass of these particles and the movement of those particles are going to create more energy, therefore be at a higher temperature, even though the particle speeds are the same. Gas pressure is also going to be greater in sample B. Sample A and sample B, 34 and 44, 680 and 720. Both of those are larger in B and the same number of particles in each. We're going to say that B has the larger pressure and temperature. Nice work. Hope that helps you get a good score above an 80 on both of those activities. Submit those today, and I'll be able to get those in the gradebook as soon as possible. God's blessings.